Hey kids, it's Raz. Sorry I just cut that last video. That was just going to be way too long. That was kind of more the basics, review a bio. Now we're going to get into some of the more complex stuff. So I'm going to jump back into this parental care. So we're talking about how populations grow and change. And one of the things we also look at is sort of how they reproduce and how their offspring survive. Because the more offspring that survive, obviously, the bigger that population is going to get. So living things can fall under two categories: K selected or R selected. Think of K selected as more of like a quality approach and R selected as more of a quantity approach. So K selected. K selected species tend to have very few offspring and they care for them for a very long time. Okay. So humans are K selected, right? We have a couple kids and we take care of them for many, many, many years, right? Typically, these living things will reproduce multiple times within their life, right? So there's not just like one season that they're reproducing. And usually, case selected species have a pretty long lifespan. And it often takes a long time to hit sexual maturity. So they're dealing, you have many, many, many years where they're just growing up. So because of that, they have a low, what we call biotic potential. So biotic potential is just how many living or how many offspring any living thing can have. Lower biotic potential means we're going to have a slower population growth rate because you can have fewer kids at a time. These species, K-selected species, are more likely to be disrupted by environmental change or invasive species or by human impact. So we hear quite a bit about manta rays, or I do because I read stuff. But manta rays are protected. They are a protected species, but they were hunted quite regularly for their gills. And manta rays may have one or two kids every like 4 years. So if you're impacting that one generation of that population, it's going to take them a really long time to rebound. They're heavily affected by that. Now, on the other side of the coin, we have R selected. So when I think of R selected, I think reproduce, because R selected are all about reproducing. And they're going to have lots of offspring, but not provide very much care for them. Think of the mama sea turtle that lays hundreds of eggs on the beach and then goes and swims off and says, sorry, kids, fend for yourself, right? And oftentimes these living things only will reproduce once. So it's one time, they're laying that massive eggs, they're done, okay? Often have a shorter lifespan. Not always. The sea turtle example doesn't go well there, but usually shorter lifespan. Think like insects, right? Their lifespan pre-sexual maturity is very short. Like they hit that quickly. High biotic potential, high population growth rate. These things do really well with changing conditions. So environmental conditions changing, they're usually all right. And they're much more likely to be invasive because they have so many offspring at once. Okay, so that parental care is going to come into play when we start thinking about survivorship curves, which is next. Like I say all the time, guys, this is a spectrum. So we're going to have like super K selected species and super R selected species and some that kind of fall in the middle, right? So just be aware of that. I guess I could mention this too. This is actually a great chart that I pulled right from your book, Table 6.1, that just has kind of the overview of all of that. All right. That little froggy over there, by the way, those are little baby frogs on its back. Carries them around everywhere until they're ready to go. It's the cutest little thing. Anyways, that would be high level of parental involvement. All right. So I already talked about most of this. I'm going to kind of skip over this. Just know that K-selected species are more likely to be taken over by invasives and R-selected are more likely to be invasive. I'm good with that. All right. So now we get into survivorship curves. So a survivorship curve is just a line that shows the survival rate of a group of kind of similarly aged individuals from birth to death. Okay. So when you see like for type 3, for example, that line drop off quickly, that means that a very small percentage of that population are going to survive like infancy or like early adulthood or childhood. Type 1, where you see it kind of flat along, that means that most of those individuals are going to survive their childhood and it's not going to sort of drop off until later in life. They have a longer lifespan. Okay. Now, we're going to do a lot of work with this in class, so I'm not going to spend a ton of time talking about this here. I'm actually going to skip over this slide in this video completely. This may be worth revisiting once we do this activity in class. Okay. Actually, wait, go back to here. Just know that with this type 1 curve, like we said, they have a longer lifespan, but they typically have more parental care. So think about which type of species, R or K, has more parental care, right? If living things are going to make it through their infancy, they're having somebody help them along. Type 2, kind of even level throughout. We'll talk about why that is. Again, I don't want to give it away if you're doing this in class. And then that type 3 curve at the bottom, again, that's not a lot of parental care, not a lot of offspring are actually going to be surviving to reproduce. So you get that kind. So again, think about, is that R selected or K selected? Which is it? All right. So your job after this one is going to be to look at this curve that I'm giving you here and describe which survivorship curve, 1, 2, or 3, would this be, and justify why that data represents that curve. All right. Happy FRQ writing. I will see you back here soon. Bye.